All right, so we can use our sum and difference formulas to help us with trig identities as well. In this case, we've been asked to simplify this expression to a function of a single angle. So cos of x minus y, that's cos x, cos y, plus sine x, sine y. That whole thing is being multiplied by cos y, minus, this is going to be sine x, cos y, minus sine y, cos x, times sine y. Oops. Okay, so now I want to expand this, and I'm going to end up with cos x times cos squared y plus sine x sine y cos y minus sine y sine x cos y plus sine squared y cos x. So looking at, let's see here, I'm going to change colors. Looking at these two terms, I can take those, factor out a cos x, and be left with cos squared y plus sine squared y, which I know, of course, is 1. And now looking at these terms, they're exactly the same, but I'm subtracting them. So that means that I'm going to end up with 0, which leads me to a single angle, trig function of a single angle, which is just cosine of x. So that was fun. Let's see if we can prove this next one. Remember, with proof, I can only work with one side. My right-hand side here seems more complicated, so that's the side I'm going to work with. So a half cos x plus cos y, cos x plus y, cos x cos y minus sine x sine y, and then plus, that's going to be cos x cos y plus sine x sine y. And I can see again that I have some canceling that's going to happen. And I have 2 of those. When I multiply them by the half, I'll get a half times 2 cos x cos y, which of course is just cos x cos y, which is what I wanted to prove on the left-hand side. I'm going to leave you to do this one, but go ahead and use the sum formula. We know that this is just a shift of a full period for tan, so of course it's the same. So graphically, I know that. But now use the sum formula to also prove it. And that is your notes for sum and difference identities. Here's some practice down here. And if you have questions, put them in the document. See you later.